Now, I want to make a video, but I don't want to explain every single question. So how about you guys pick one?
5. No le hagas caso a ella, no le hagas caso a ella.
We could do a couple. We could do a couple.
6, 5, and 3.
Yeah. Sure. All right. Ladies and gentlemen, let's take a look at number 6. Now, we've been graphing growth functions, and now we're doing decay functions. It's the same exact process. Step 1 would be ignoring the h and k. So box in your function without including that k value. Of course, there's not an h value. In algebra 2, you're going to have h values. This is a decay function because the base is less than 1. Yeah, half is going to make anything smaller. Half of 8 is 4. Half of 4 is 2. Right? That half is going to make anything smaller, so it's a decay function. But anyway, you ignore the k value. You make a quick xy table for that function inside the box without h or k. You're going to use consecutive integer inputs like -3, -2, -1, 0, 1, 2, 3. And you're going to plug in the easiest input, which happens to be 0. When you plug in 0 right here, anything to the 0 power is 1, but you have to multiply it by 4, which will give you a 4. So for the input 0, you get the output 4, and that is a coordinate. Is everybody with me?
Yeah.
So that wasn't difficult. All we did was plug in a 0 right there. We got out a 1. 1 times 4 is 4, done. Now, you could continue to plug in a 1, do the math, get an answer. Plug in a 2, do the math, get an answer. Plug in a -1, do the math, get an answer. But it's easier to simply take that answer and multiply it by half. So from this answer to the next one, I am going to multiply it by half. Now, if this would have been a 3, instead of a half, I'd multiply it by 3 and I would I'd get a 12. If this were a 5, I'd multiply it by 5 and I'd get a 20. But it's not a 5, it's not a 3, it's half. So I'm going to multiply 4 times half, and what do I get? 2. And then I multiply 2 times half, and what do I get? I get 1. And if I multiply 1 by half, what do I get? 1/2. And I mean, I could keep going if I wanted to. I could say, okay, 4, 5, 6, and I could say 1/2. 1/2 times half is what? 1/4. And then 1/4 times half is 1/8. And then 1/8 times half is 1/16. And we know it gets smaller and smaller and smaller. It's pointless. It's actually pointless to do this. You already know that half of 1 is half. Half of that's 1/4. It's going to get smaller and smaller. So, again, what did I do to get from the answer 4 to the answer 2? I multiplied by half. So if I'm multiplying by half this way, backwards, what's the opposite of multiplying by half? It's dividing by half. Now think about that, guys. Dividing by half is really the same thing as multiplying by the reciprocal, which is 2. So instead of saying, I'm multiplying by half this way, so now I'm dividing by half. Instead of saying dividing by half, you're going to be multiplying by 2. Think about this. 1/2 times 2, it really is 1. 1 times 2, it really is 2. 2 times 2, it really is 4. 4 times 2, what's this next one? 8. And the next one? 16. And the next one? 32. But see, those right there are pointless. You're not going to use this one on the graph. You're not going to use this one on the graph. So you didn't even have to use those really, or even write those down. So let's graph what we have right here, and let's just graph the ones that make sense to us. Let me go with the -1 and 8. -1 on the x, 8 on the y, it's right here. Let's go to 0, 4, 0, 4, 1, 2, 3, 4, it's right here. Let's go to 1, 2, 1, 2 is right here. Let's go to 2, 1, 2 on the x, 1 on the y, that's right here. Let's go to 3 and then half. Think about that. 3 on the x, 1, 2, 3, and then only halfway up. So let's put that 3 and then up half right there. And we know that it continues to get what? As you go this way, it continues to get what? Smaller and smaller and smaller. So you could just draw dots that are closer to the line. And right here, it already looks like I'm drawing dots on the line. I mean, I am drawing them on the line. But we know that it doesn't really touch. It just infinitely approaches. So this would be the asymptote of the parent graph, but we don't want this actual parent graph. We want the entire thing, including that minus 9, the k value of negative 9. So what does this k value of negative 9 tell us? You're going to shift the whole thing 9 units down. So I would start by looking at the first asymptote, the parent graph asymptote of 0, y equals 0, and shifting that asymptote down all the way to y being negative 9. There's my new asymptote at y being negative 9. And yes, I'm going to take every one of these coordinates and I'm going to shift it 9 units down. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I put a dot right there at 9. This next one, shift 9 down. 1, 2, 3, 4, 5, 6, 7, 8, 9 right there. This next one, 9 down, is going to be right here. And the next one, 9 down, it's going to be right here. And as you could see, the next one that's at halfway, going halfway 1, halfway 2, halfway 3, all the way down, you're going to halfway right here. That's going to be your 9th unit down from the halfway. So you put a dot right there. And as you can see, it's approaching that asymptote that we already shifted 9 units down. And that's it, guys. I mean, this is your graph. Let me do it in black right here. Put an arrow, put an arrow. That's your exponential decay graph right there. Now, we could answer several questions with regards to this exponential decay. First of all, I would put 2 x's on the parent graph. That way, when I'm grading it, I don't make the mistake of thinking that this was your answer up here. This is your answer. That's why I put 2 x's right there. Okay, so what could we ask about this decay function? Well, how about the domain? The domain are your x values. You're going to say x equals all real numbers. How about your range? Your range are your y values. And this graph right here is either above or below your asymptote. Now, how about this? We haven't even stated the asymptote. That's something very important to state. Asymptote. What is the asymptote? But you want to say the equation y equals negative 9. Y equals k. That's your asymptote. So if you go to the horizontal line, y equals negative 9, of course, you're going to get right here, y equals negative 9. That's your asymptote. From left to right, it really does decay towards that asymptote, infinitely approaching it but never actually touching it. So that's a very important bit of information that we need about this graph. The domain is x equals all real numbers. The range is either above or below this asymptote. What do you say? Above. It's above. So how do I write that in terms of an inequality? Y is greater than what? Negative 9. And that's about it. Oh no, we could say y-intercept. Where does this cross the y-axis? Now don't use this one, right? You're not plugging in 0, getting out of 4. Yeah, but right here, negative 1, 2, 3, 4, 5. So 0, negative 5. 0, negative 5 is your y-intercept. Now you could have found that y-intercept visually by just seeing where it crosses. Or you could go back to the original entire equation and plug in 0 for x. That would be a 1. 4 times 1 is 4. And then 4 take away 9 is negative 5, the output. And that's about all you could state on this exponential decay function. So as you can see, you graph it almost the same way as the exponential growth. And you use the same concept of getting one simple answer like 4 and then multiplying it by half. Going backwards, it'd be dividing by half, which is multiplying by 2. So everything's done pretty much the same. Should we do another or should you guys just try it?
Yeah, 5.
5?
Yeah.
Okay. I guess we're going to do 5. I'm not going to do all of them though.
Yeah.
All right, so step 1, ignore h and k, box it in. There is no h, but in algebra 2 there is. The k value is negative 6. We're going to ignore it. We leave it outside the box. Let's go to a xy table, and let's plug in consecutive integer inputs. Negative 3, negative 2, negative 1, 0, 1, 2, 3. What's the easiest number to plug in?
0.
When you plug in 0 up here, That's 4 to the 0, which is 1. And then what's 1 times 1/8? 1/8. It doesn't change. Anything times 1 doesn't change. It stays the same. So when I plug in a 0, I get out a 1/8. Are you with me? Now, this is an output. This is an answer. To get to the next answer, all I have to do is multiply by this, by 4. So if you don't see it clearly that the answer is half, go ahead and show your work somewhere. I'm actually gonna show my 1/8. I'm gonna draw it up here, 1/8, and well, that's 1/2. Let me see it, 1/8, and then I'm gonna multiply it by this factor of 4. So I'm gonna put 1/8 times 4. So what does that give me? That gives me 4/8. But what does 4/8 reduce down to? 1, 2, 1 over 2, 1/2. So this answer right here is 1/2. Does that make sense? Yeah. Now, if I wanted the next one, I would have to multiply 1/2 to get to here. I'd multiply it by 4. I mean, if you don't see it clearly, go ahead and show your work. What is 1/2 times 4? Well, you put it over 1, and you'll get 4 over 2, right, as an answer? And what is 4 divided by 2? It's 2. That's how we get the next answer, 2. What would the next answer be? 8. That one's easy. And then the next one would be 32, right? If you went down one more, if you said, okay, I want to plug in a 4, what do I get out? I get out of 32. Because 8 times the base 4, that'll give me the next answer, 32. Do we understand that we got the simple answer 1/8, and then we multiplied it by 4 and we got the 1/2? Multiplied it by 4, got 2. Multiplied it by 4, got 8. Make sense? Yeah. So if going this way is multiplying by 4, what's going the opposite way? Dividing by 4. Or you could think of it as multiplying by 1/4, right? Instead of saying I'm dividing by 4, you could say I'm multiplying by 1/4. 8 times 1/4 is 2. 2 times 1/4 is 2/4, which reduces down to 1/2. 1/2 times 1/4 is 1/8. And 1/8 times 1/4 is what? 1 over 32. Now, at that point, you already know it's getting closer and closer to 0. I mean, it's pointless to multiply 1 over 32 by 1/4, and you get 1 over some huge number. It's really close to 0. So just with a couple of these coordinates, you'll be able to draw your graph accurately. Like the 3/8. Let's go to 3/8. 3 on the x, 8 on the y. 3, 1, 2, 3 on the x, 8 on the y. There it is. Let's go to 2, 2. 2 on the x, 2 on the y. There it is. Let's go to 1 and then half. So from here, let's go 1 and only halfway up. So we're going to put a dot right there. 1 on the x, halfway up on the y. Is everybody with me? Yeah. Now, if I go 0, 1/8, 1/8 is hardly anything. 1/8 is hardly anything. So 0, 1/8, 0 on the x, 1/8 of the way up. You're not going to be able to draw it accurately. It's super close to the x-axis, super close to the origin. So you would put it right there, 0 and 1/8 of the way up. And we know if we go to -1 on the x and then 1 over 32, forget it. It looks like it's on the line itself. Do we understand? Yeah. So this is our asymptote. Going towards the left, it infinitely gets closer to the asymptote, infinitely gets smaller. Going to the right, infinitely gets bigger. But then again, this is our parent graph. What do I still need to do to this whole, to all these coordinates? What do I need to do? What do I need to do? Move them 6 down. Move them all 6 down. So let me go to my nice coordinates. I want to go to this coordinate right here, and I want to move it 6 down. 1, 2, 3, 4, 5, 6. I want to do this new dot in red. It's right there. This one goes down 6 units. 1, 2, 3, 4, 5, 6. Right there. This halfway one goes down 1 to the next halfway, 2 to the next halfway, 3, 4, 5, 6 right here. And of course, our asymptote that was up here originally at y equals 0 on the parent graph, I need to shift that also 6 units down. That's my new asymptote, y equals -6. So if I shift it 6 units down, I'll end up right here. That's our new asymptote. So if I connect these red dots, just connect those dots, it curves this way, and you know it's going to curve to that asymptote. Then that's your graph. That's your final graph right there. And that is an exponential decay function, and the asymptote is, I believe, at -6 right here. And why is it -6? Because the k value is -6. And you could state all the details about this red exponential growth function. Again, it's growth because the base is greater than 1. It actually grows from left to right. It grows away from the asymptote. But what about the domain? What about the domain here? X equals all real numbers. What about the range? Y is what? Y is greater than -6. Perfect. And what about the asymptote itself? You say y equals -6.
Because it passes through the asymptote?
Because, what was the question? Okay, what else could we say? We could also ask for the y-intercept. What is the y-intercept? Where does it cross the y-axis? Well, it crosses right here, and that's kind of weird. So I guess the safest thing to do, it's either you go to the 0, 1/8 and then subtract 6 from here. And if you subtract 6 from here, that would move it down to -5 and 7/8. That one's kind of weird. So 0, -5 and 7/8. I'm done. Keep working.